So today I'm briefly going to talk about solving linear systems by multiplying first. This is section 7.4. I like to call this solving linear systems by elimination using modifications personally, but it's all the same. Just essentially it's an addition to 7.3. It's a continuation of 7.3 where we're solving via linear systems. In 7.3, if you remember, let me do a quick problems from 7.3. For example, this is number 3 from page 394. If you had x plus 2y equals 13, and then you had negative x plus y equals to 5, this was a very simple problem for elimination. You would add the two equations together, and you would add them because by adding you would eliminate the x. If you subtracted, none of the variables would eliminate. So by adding the two together, you would go x plus x, that's 0, 2y plus 3y, that's 2y plus y, that's 3y, 13 plus 5, that's 18, and you divide both sides by a 3, and y equals to 6. Then you would substitute that 6 in for the y into either one of those y's. For example, if I did substitute it into the bottom one, and then I would get my negative x equals to a negative 1, because I'm going to subtract 6 from both sides, and x equals to 1. And that was a very simple solution. It was a very simple elimination problem, but the whole point was in 7.3, one of the two variables would always match up. You would have x and x, y and y, 3y and 3y, 5x and 5x. One might have been negative or not, but they would always have the same coefficient, which allowed you to eliminate them. But let's see what happens if we have a problem like this one. 5x plus 2y equals to 16, and 3x minus 4y equals to 20. So again, it's a system of linear equations, and if we're asked to eliminate this, if we're looking at it, we can't really eliminate the x or the y as it stands, because no matter if you add or subtract, if you add the two together, 5x plus 3x, that's 8x, 2y and negative 4y, that's negative 2y, none of the variables eliminated. If you subtract the two, 5x minus 3x, that's 2x, 2y minus negative 4y, that's 6y. Again, nothing eliminates. So you can't use elimination here. You could always use substitution or graphing, but those are typically more cumbersome methods. So let's see if we can do a little bit of modifications to help us make this particular problem solvable through elimination. Let's look at the coefficients of both the x and the y. So in front of the x in the first equation we have a 5. In front of the x in the second equation we have a 3. What's the greatest common factor for 5 and 3? The smallest number that they both go into evenly, and that's 15. So if I convert both equations so the x's are 15, I would be able to eliminate that x out. To do that, I would need to multiply both equations by a number, the top one by a 3, the bottom one by a 5, and I could do that. So that would be a possibility. Multiply the entire top equation by 5, the entire bottom equation by 3 to get both x's with the same coefficient. And I can multiply the equation throughout by the same number, because as long as I change both sides of the equations, I can multiply it by whatever I want. So that's one possibility. Well, let's look at the coefficients of y. We have 2 and 4. I'm going to ignore the negative 4 right now. It's a negative 4, but I'm going to ignore that for right now. 2 and 4. The GCF, or the greatest common factor, for 2 and 4 is 4. So 4 goes into 4, 2 goes into 4. And look, the bottom one is already a 4. I don't need to do anything to the bottom equation, and I just need to change the top equation for both coefficients to be 4. That's a little simpler than changing both of the equations to match the coefficients of the x. So let me do that. And let's see what happens. So I'm going to multiply the entire top equation by a 2. And I'm going to rewrite that right over here. 2 times 5x, that's 10x. 2 times 4y, that's 4y. Sorry, 2 times 2y. Yeah, okay. It's the end of the day, sorry. 2 times 16, that's 32. Alright, now I'm going to rewrite the second equation just as is on the bottom of the first one. Okay, so let's take a look. Can I eliminate this system now? Still can't eliminate the x's, but the y's, because I modified the top equation. Now it's a 4y and a 4y. Yes, this is a negative 4y, but because they have the same coefficients, I can now do elimination. I'm going to add the two together. 13x, 4y plus a negative 4y, that's gone. Also 52. Now to get rid of the 13, I would divide both sides by 13. And x equals to a 4. Now of course that's not the end, and all I would need to do would be to substitute this x into one of these two x's of the two original equations, doesn't matter which, to get my y, and then I would have a complete answer. I'm not going to do that here because that was what we did in 7.3, so if you still need help with that, you're welcome to watch the videos for 7.3. But the whole point was we took a system of two linear equations which at first glance were not eliminatable. Not sure that's a word, but you were not able to use elimination to solve that particular system. And we like to use elimination because it's simple. So by a little bit of modification, we can convert that system into a form where we can use elimination. Again, you could have modified the coefficients of the x's, made them both 15, but that would require modifying both the top and the bottom equation. Modifying the coefficients of the y, I'd require only modifying the top one. Since the GCF for the coefficient of y is 4, and the bottom one is already a 4, all you have to do is modify the 2. For the x, the GCF was 15. You need to modify both top and bottom to make them both 15. So you could go that route. It's going to be more work, and it's going to result in the same answer. But since the whole point of elimination is to make it nice and quick, you should always go for the quick method. So let's do another one. Let's do this particular problem. 6x plus 5y equals 219. 2x plus 3y equals to 5. Now again, it's a system of linear equations, and we can always use substitution and graphing as well, but we're concentrating on elimination since that's the simplest method. Now just at a glance, again, no matter if you add or subtract, you cannot get this system to eliminate a variable. If you add them, 6x plus 2x, 8x, 5y plus 3y, 8y, still both there. If you subtract them, it would be 4x, 2y, both still there. So we can't use elimination. We can, just requires a little bit of work and a little bit of modification. So let's take a look at the coefficients of the x and the y. So for the x, the two coefficients are 6 and 2. The GCF, or the greatest common factor for those two numbers, is 6. 6 goes into 6, 2 goes into 6. And since the top equation already has that, the 6, all we need to do is modify the bottom one. So the coefficient for x is a 6 there as well, and we'll be able to eliminate. Let's look at the y's. Just like in the last problem, the coefficients of y are 5 and 3. The GCF for 5 and 3 is 15. So in order to modify the equation and eliminate y, we'd have to multiply the top by a 3 and the bottom by a 5 to get 15 as a coefficient for y. We could do that, but again, modifying both equations versus modifying just one equation, modify just one equation. So we're choosing to modify the bottom equation for the x. So we're going to multiply everything by 3 because 3 times 2 gives us that 6. And if they're both 6x's, we can eliminate. So I'm just going to rewrite the top equation right here. 3, and then the bottom one, 3 times 2x is 6x, exactly what we want. 3 times 3y is 9y. 3 times 5 is 15. Here, I can't use addition because if I'm trying to eliminate x and I use addition, I'll get 6x plus 6x, 12x. It's not going anywhere. But if I use subtraction, now I can do some work. 6x minus 6x, 0. 5y minus 9y, negative 4y. 19 minus 15 is a 4. To solve for y, I just divide both sides by a negative 4. And y is a negative 1. Again, I'm not going to solve this to completion. If you were to do that, you would just substitute the negative 1 for the y over here or over here to get x, but this was done in section 7.2 and 7.3. So refer to those videos if you still need help with that part. So I'm just going to solve it up to this point. But again, the whole point was that we used a very simple elimination by modifying the equations so that we got an eliminatable variable. So before it was 6x and 2x. Can't eliminate that. After modification, 6x, 6x. We can work with that. You could have done that with the y's as well. Let me show you that you can, but it's just a little bit more cumbersome. So right down here, I'm going to write the first and the second equations real quick. I'm not going to solve it to completion. I'm just going to show you that you can modify the other variable as well. So the GCF for 5 and 3 is 15. So if I'm going to eliminate y, I need both of them to have the same coefficient, in this case 15. To do that, I need to multiply the top by a 3, because 3 times 5 is 15. The bottom one by a 5, because 5 times 3 is 15. So I'm going to do the top one over here. 3 times 6, that's 18x. 3 times 5y, that's 15y. And 3 times 19, that's going to be 48. I'm going to do this one underneath it. 5 times 2x, that's 10x. 5 times 3y, that's the 15y, what we want. 5 times 5, that's 25. And I would have to use subtraction here to get rid of these two. And again, it would work, but now I had to do 2 sets of modifications. That takes time. And take a look at this versus this. The numbers and the coefficients are just all small over here. Easier math. You can still work it out. 8x plus 0 equals to 48 minus 25. Whoops. 3 times 19, that's not 48. So you can make mistakes once you get to big numbers as well. So that would be actually 57. Sorry about that. Yeah. Again, end of the day, my bad. So that would be now 57 minus 25. That's going to get us 32 if my math is accurate. And then if you were to solve for x, x would be 4. And then you would plug this x into one of the x's here and get y, which would have been the same y that you got here. So the whole point is you can modify for the x or the y to get those eliminated. But this process is so much simpler than this one, as you can see. So I have done some of the homework problems. I've worked them out for you. They're posted as a separate video. So best of luck, and thank you very much.